The moment astronomers realized what they were seeing, the atmosphere around this object shifted from routine observation to intense scrutiny, because this was not supposed to happen. When 3I Atlas was first detected, it was categorized as another interstellar visitor, unusual in trajectory and speed, but still expected to behave like every other object that has wandered into our solar system from beyond. As it approached Jupiter's massive gravitational influence, scientists around the world prepared for a familiar sequence of interactions: tidal effects, minor outgassing if volatile materials were present, and predictable disturbances in Jupiter's already chaotic magnetosphere. Jupiter, after all, is a planet that constantly reacts to its environment. Its magnetic field is enormous, stretching millions of kilometers into space, trapping charged particles and producing intense radiation belts, radio emissions, and auroras so powerful they dwarf anything seen on Earth. Objects passing through this region usually leave a clear fingerprint, one that fits neatly into existing models developed over decades of observation. But in this case, something didn't fit. Shortly after 3I Atlas crossed a specific boundary within Jupiter's magnetosphere, instruments monitoring radio frequencies and plasma behavior registered a sudden, sharply defined anomaly, a spike that appeared, peaked, and vanished far faster than expected. At first, researchers assumed it was an instrumentation issue, a calibration error, or interference caused by solar activity, because such clean, isolated disturbances are rare in Jupiter's turbulent electromagnetic environment. However, when independent observatories and monitoring systems detected the same signature at the same time, the possibility of a simple error quickly faded. The anomaly appeared to coincide precisely with the object's position relative to Jupiter, not before, not long after, but during a narrow window when 3I Atlas was interacting with a specific region of charged particles and magnetic field lines. This timing alone was enough to make scientists pause, because Jupiter's magnetosphere is vast and messy, and reactions usually smear out over time and space, not form brief, localized events. What made the situation even more unsettling was the nature of the response itself. The signal did not resemble the usual patterns produced by comets shedding material, asteroids reflecting radiation, or interstellar objects interacting passively with plasma. Instead, it looked more like a triggered reaction, as if the presence of 3I Atlas altered the local environment just enough to push Jupiter's electromagnetic system into a short-lived state change. No one involved claimed this was intentional, intelligent, or artificial, but the language used internally by researchers reflected genuine confusion. Words like unexpected, non-standard, and unclassified interaction began appearing in preliminary notes. Jupiter's magnetosphere is known to respond strongly to its moons, especially Io, which pumps material into the system and drives powerful currents, but 3I Atlas is not a moon, not bound to Jupiter, and not expected to influence the system in such a distinct way. The response was also unusually quiet in certain wavelengths where follow-up emissions would normally appear, suggesting that whatever happened was either extremely brief or limited to a narrow physical process. This absence of secondary effects became just as puzzling as the initial detection. In most known cases, when Jupiter's environment is disturbed, the planet answers back with lingering signals, extended auroral activity, or delayed plasma oscillations, but here the system seemed to reset almost immediately, as if the disturbance had never occurred. That behavior forced scientists to consider more exotic, yet still natural explanations. One possibility discussed was that 3I Atlas may possess an unusual surface composition, perhaps containing highly conductive materials, rare ices, or structures capable of interacting efficiently with magnetic fields. Another idea suggested that the object might be rotating or tumbling in a way that temporarily aligned it with Jupiter's field lines, creating a momentary coupling that released energy before breaking apart. There was also speculation that the object could have expelled a short burst of gas or dust at precisely the wrong moment, triggering a localized chain reaction in the plasma environment without leaving long-lasting traces. Each of these explanations remains theoretical, but the fact that none could be ruled out immediately speaks to how poorly this interaction fits existing frameworks. What made the moment feel even more significant was how quickly attention shifted. Observatories that had been casually tracking the object suddenly reprioritized it. Data archives were reopened. Previous observations were re-examined frame by frame to see if similar interactions had been missed before. Scientists were not chasing aliens or messages, but they were clearly facing something unfamiliar, and unfamiliar phenomena demand caution. The word responded does not imply communication, but in physics, a response simply means a system reacted measurably to an input, and in this case, Jupiter's system reacted in a way that suggested a direct and immediate influence from 3I Atlas. That alone is enough to make this event noteworthy. Interstellar objects are rare, and interactions between such objects and planetary magnetospheres are even rarer, meaning there is very little historical data for comparison. Every new observation carries disproportionate weight, and this one, brief as it was, refused to behave quietly. Even more intriguing is that the response occurred near Jupiter, a planet whose environment amplifies even small effects into observable phenomena, acting almost like a natural detector for unusual physics. If 3I Atlas had passed closer to Earth or Mars, the interaction might have gone completely unnoticed. Instead, Jupiter's immense magnetic presence turned a subtle interaction into something detectable across millions of kilometers. That realization alone reframed the event, because it suggests that similar encounters may have happened before, hidden in less extreme environments, leaving no trace for us to find. As data continues to be analyzed, scientists remain careful with their language, emphasizing uncertainty and resisting dramatic interpretations, but behind that caution lies genuine excitement. The universe does not often hand us moments where an object from another star system appears to provoke a measurable reaction from a planet as massive and complex as Jupiter. Whether this turns out to be a rare magnetic coincidence, an unknown physical process, or evidence that interstellar objects are far more diverse than we currently understand, one thing is already clear: during that brief window near Jupiter, 3I Atlas did not simply pass through space as a silent traveler. Something happened, something responded, and whatever the final explanation may be, it has already forced scientists to stop, look closer, and admit that once again, space has surprised us. As the initial shock of the detection settled, scientists turned their attention to what happened next, and in many ways, the aftermath proved even more unsettling than the event itself, because the response near Jupiter ended almost as abruptly as it began. Within minutes, the anomaly faded back into the background noise of Jupiter's magnetosphere, leaving behind no dramatic flare, no prolonged emission, and no obvious structural change in the surrounding plasma environment. For researchers accustomed to studying Jupiter, this was deeply unusual. The planet's magnetic system is famously persistent. Disturbances tend to echo, cascade, and evolve over time, producing secondary effects that can be tracked long after the initial trigger. Yet in this case, those expected aftershocks never materialized. Instead, the system appeared to stabilize almost immediately, as if the interaction had been tightly confined in both space and time. This absence of lingering signals forced scientists to confront a difficult question: how could an object passing through one of the most energetic environments in the solar system produce a measurable response without leaving a lasting footprint? One explanation gaining attention is that the interaction occurred at a very specific boundary within Jupiter's magnetosphere, where small changes can briefly amplify before being rapidly absorbed by the surrounding system. If 3I Atlas crossed such a boundary at just the right angle and speed, it could have triggered a momentary reaction that collapsed as soon as the conditions shifted. Another hypothesis suggests that the object itself may have undergone a short-lived physical change, such as a sudden release of material or a temporary alteration in its surface properties, which quickly dissipated before follow-up observations could capture it. This would explain why the response appeared sharply defined but left no trail behind. What complicates matters further is that subsequent monitoring of 3I Atlas showed no obvious signs of damage, fragmentation, or sustained activity, meaning whatever happened did not permanently alter the object in a detectable way. That detail is crucial, because it implies the interaction was not violent, but subtle, precise, and possibly dependent on very narrow conditions. Scientists also examined the possibility that the response was caused by an internal process within Jupiter rather than the object itself, such as a spontaneous magnetospheric fluctuation that happened to coincide with 3I Atlas's position by chance. While this cannot be ruled out, statistical analyses suggest the timing was unusual enough to warrant serious attention, especially given that multiple instruments recorded the anomaly independently. To understand what might have been missed, researchers began comparing the event to known interactions between Jupiter and its moons, particularly Io, which is famous for generating powerful electrical currents and auroras through its interaction with the planet's magnetic field. However, those interactions are continuous and sustained, driven by repeated exchanges of material and energy, whereas the response associated with 3I Atlas was singular and fleeting. This contrast reinforced the idea that scientists were not witnessing a familiar process scaled down, but something fundamentally different. The challenge now lies in interpretation, because science depends not only on what is observed, but on what can be tested and repeated, and this event may never occur again in exactly the same way. That uncertainty has prompted a renewed focus on future interstellar visitors, with researchers discussing how to better instrument the solar system to capture similar interactions in greater detail if they happen again. Some have even suggested that Jupiter could serve as a natural laboratory, its magnetosphere acting as a massive detector for subtle properties of passing objects that would otherwise remain invisible. In this sense, the encounter with 3I Atlas may represent a turning point, not because it provided clear answers, but because it exposed gaps in our understanding. It revealed how little we know about the full range of behaviors interstellar objects can exhibit and how complex planetary environments can respond to them in unexpected ways. While public speculation has raced ahead, scientists remain careful, emphasizing that extraordinary claims require extraordinary evidence. Still, behind that caution is a quiet recognition that something important may have happened, even if its true nature remains unclear. The universe often advances our knowledge not through dramatic revelations, but through small, puzzling inconsistencies that refuse to go away, and this brief, vanished response near Jupiter fits that pattern perfectly. Whether future analysis reduces it to a rare coincidence or elevates it into a new category of interaction, the event has already achieved something significant. It has reminded us that space is not a static backdrop, but a dynamic, reactive system, and when an object from another star system passes through it, the results can be stranger, subtler, and more surprising than we ever expected.